Hi, my name is Prisca, and today I will be speaking on the effects of Parkinson's disease music and dance training on beat perception and production abilities. And this project is supervised by Doctors Emily Reddy and Jessica Grahn. Beat perception is our ability to perceive a consistent pulse in complex stimuli, such as music. And beat production is our ability to synchronize our movements to the stimuli in a timely manner through clapping, tapping, or even dancing. And just to provide an example of what this process looks like, here's a video from Taylor Swift's concert. Notice that the crowd is instinctively clapping to her music without anyone leading. If you listened carefully, you could tell that the claps are highly variable in timing. Some people were coming in too early while others were coming in too late. Factors that affect the accuracy of these abilities, such as music or dance training, and whether they may mitigate some of the timing deficits observed in Parkinson's disease patients, will be explored in the study. Parkinson's disease is characterized by progressive cell death of dopaminergic neurons in the basal ganglia, as we can see here by the reduced amount of dopaminergic neurons. As beat processing occurs in these areas, Parkinson's patients are impaired on rhythm discrimination and motor timing tasks. While music training hasn't been found to influence the basal ganglia particularly, musicians have neural differences associated with their training, such as a larger auditory cortex and greater white matter connections between the hemispheres, as seen in these larger white matter tracts. And in terms of behaviors, musicians have been found to have superior beat processing abilities compared to non-musicians. And similar to musicians, dancers have enhanced gray and white matter networks in temporal and motor brain areas, as well as connectivity between the two hemispheres, as we see here in these white matter tracts. And studies have found that, like musicians, dancers also have superior beat processing skills. So people show a striking range in how accurately they both perceive and move with a musical beat. These abilities are positively impacted by music and dance training, but negatively impacted in Parkinson's. However, little is known about the combined impact of these previous life experiences and Parkinson's on beat processing abilities. So our goal in the study was to assess the effects of music and dance training in both healthy and Parkinson's populations, as well as evaluate whether the beat alignment test could capture beat perception and production differences among musicians and dancers. And we predicted that Parkinson's patients would demonstrate lower beat processing accuracy overall, that music and dance training would increase this accuracy, and while the basal ganglia is impaired in Parkinson's patients, the neural and behavioral changes associated with music training may still be preserved despite disease state. So we reasonably predicted that Parkinson's patients with previous music or dance training would have more preserved abilities compared to those without. And just to note, we were examining whether music or dance training compensates for reduced beat processing ability. And we didn't predict a cumulative effect of music and dance training, but it is possible that it could be cumulative. And this was an opportunistic study collating data collected over many studies in the lab over several years, explaining how we had such a big sample size comprised of young adults, older adults, and Parkinson's patients. And this also explains why we had more healthy adults compared to Parkinson's patients, and why we had less participants with dance training, especially with Parkinson's. And we chose the beat alignment test because it has been extensively used in the literature to assess beat processing abilities in both healthy and clinical groups. On the beat perception component, participants were instructed to listen to a series of music clips with overlaid tones and then judge whether the tones were on or off the beat. So here's an example. And that was an offbeat track. And another one. this was an on-beat track. And on the beat production task, participants were instructed to tap in time to the beat of the music, and they were measured based on phase matching or asynchrony, and tempo matching or coefficient of deviation. And we conducted 2 separate ANOVAs for music and dance training and then followed up with sample main effects and post hoc comparisons. We couldn't conduct a 3-way ANOVA because we didn't have enough Parkinson's disease patients with dance training. And we categorized training based on 0 to 2 and 3+ years to ensure that we had 2 decently sized samples for our analyses while still preserving possible significant effects. And for our results in beat perception, overall, people with music training performed better than people without, as seen in these higher bars. However, the effect was only significant for younger and Parkinson's disease patients. And for beat production, notice that in asynchrony and coefficient of deviation, a higher score means less accurate tapping. And Parkinson's patients with music training performed comparably to healthy adults, as seen in this bar. However, those without music training performed significantly worse in this higher bar. And for coefficient of deviation, we found a significant difference between healthy musicians versus non-musicians, but this effect was washed out when Parkinson's disease patients were included in the analysis. And here's our dance training results. We didn't find any significant effects for beat perception or production among healthy adults. And the Parkinson's group was not actually included in our analyses due to low sample sizes, and they're here just for visualization purposes. And to summarize, we found increased beat perception abilities among musicians only. For beat production, musicians performed significantly better, while Parkinson's disease patients performed worse. Interestingly, Parkinson's disease patients with previous music training demonstrated more accurate beat production abilities compared to those without training, seen here in this bar. And it was surprising that Parkinson's patients were not significantly impaired on the beat perception task, and this result actually contradicted with a study that used a rhythm discrimination task. However, the beat alignment test contained a lot of redundant cues to the beat, which may have made the task easier than other tests. And music training related to better beat perception in young adults and Parkinson's disease patients, suggesting that having Parkinson's didn't hinder music effect on beat perception. And while Parkinson's patients without music training performed worse on beat production, that was expected, this is the first study to find that beat production abilities in Parkinson's were preserved in those with music training. And lastly, it is surprising that we did not find any dance effects on beat perception or production among healthy adults. This may not necessarily indicate true null effects, as a significant limitation is that the beat alignment test is arguably more geared towards musicians compared to dancers. In addition, we did have less dancers in our sample. And a major takeaway from this study is a more accurate beat production ability seen in Parkinson's patients with music training experience. Previous studies have correlated increased rhythm processing abilities with better music therapy outcomes, which may suggest that Parkinson's patients with previous music training are more likely to benefit from rhythm-based interventions. And future research could look at whether the positive effects of music training on beat production apply to other motor modalities, such as walking. And this could be useful in designing rehab interventions for the elderly and other clinical populations. And of course, it would be helpful to have more Parkinson's disease dancers. And lastly, special thanks to my supervisors, Drs. Emily Reddy and Jessica Grahn, and the rest of the Music and Neuroscience Lab for their guidance and support throughout this project. And thank you for your attention.